Good day everyone. Today we will tackle about t-test, also known as student t-test. So, what is t-test? A t-test is a statistical test that is used to compare the means of two groups. It is often used in hypothesis testing to determine whether a process or treatment actually has an effect on the population of interest, or whether two groups are different from one another. The t-test is a parametric test of difference, meaning that it makes the same assumptions about your data as other parametric tests. In many cases, a z-test will yield very similar results to a t-test because the latter converges to the former as the size of the dataset increases. And also, it's a powerful tool in data analysis, helping researchers and statisticians draw meaningful conclusions from their data. There are three main types of t-test: one sample t-test, paired sample t-test, and a dependent sample t-test. One sample t-test is a statistical hypothesis test used to determine whether an unknown population mean is different from a specific value. We can use the test for continuous data. Our data should be a random sample from a normal population. So I have here a situation on how to compute the one sample t-test using this formula. A company wants to improve its sales. The previous sales data indicate that the average sales of 25 salesmen was 50 per transaction. After training, the recent data showed an average sale of 80 per transaction. If the standard deviation is 15, find the t-score. Has the training provided improved the sales? So 80 is the average sales after training, 50 is the average sale before training, 15 is the standard deviation, and 25 is the number of salesmen. So our formula is t-score equals sample mean minus population mean over standard deviation over square root sample size. So let's plug in. T is equals 80 minus 50 over 15 over square root of 25. T is equals 80 minus 50 is equals to 30 over 15. What is the square root of 25? 5. So T is equals, copy the 30 over 15 divide 5 is 3, and t is equals 30 divide 3 is equals 10. Therefore, the training significantly improved sales with a t-score of 10, substantial increase in average sale. Paired sample t-test compares the mean of the variables for a single group. The procedure computes the differences between values of the two variables for each case and tests whether the average differs from zero. The procedure also automates the t-test effect size computation. In a paired sample t-test, each subject or entity is measured twice, resulting in pairs of observation. Common application of the paired sample t-test include case control studies or repeated measures designs. Calculate a t-test for the following data of the number of times people proper coffee or tea in 5 times. First, we need to add the number of people and divide it into 5. To find the difference from the mean, we need to subtract the mean into the number of people. And for square difference from the mean, we need to multiply it by itself. After that, we need to add the square difference from the mean and divide it into 4. So, let's plug in. T is equals 6.2 minus 5.6 over square root 3.7 over 5 plus 4.3 over 5. T is equal 6.2 minus 5.6 is equals to 0.6 over square root of 3.7 divide 5 is equal to 0.74 plus 4.3 divide 5 0.86. T is equals, copy the 0.6 and square root 0.74 plus 0.86 is equals to 1.6. So T is equals, copy the 0.6 over what is the square root of 1.6? 1.26 plus T is equals, so 0.6 over 1.26 is equals 0.48. Independent sample t-test. The independent sample t-test is a parametric test. It compares the means of the independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. The independent sample t-test can only compare the means for only two groups. It cannot make comparisons among more than two groups. If you wish to compare the means across more than two groups, you will likely want to run an ANOVA. Of this using this formula, so T is equals 27 over square root 5 open parenthesis 5.5 squared over 4. So T is equals 27 over squared 775 29 27 over square root 46 over 4. T is equals 27 over square root 1.5. T is equals 27 over 3.39. So let's divide. T is equals 27 divided 3.39 is equals 7.96. The t-test formula depends on the mean, variance, and standard deviation of the data being compared. The t-test formula helps us to compare the average values of two data sets and determine if they belong to the same population or they are different. We have reached the lesson. I hope you have learned a lot. Thank you for watching.